Hey there, Seahawks, it's Miss Adams, and in this video we're going to talk about polynomial functions. Alright, so the degree is the highest exponent wins. So this tells you the number of directional changes in your function. So what is the degree of the polynomials below? So the first one I have f of x equals 7x to the 6 minus 8x to the 4th minus 2. Well, the biggest exponent it has is 6, so it's a 6th-degree polynomial. The next one I have 5x equals 5 times x minus 2, minus x squared minus x to the 3rd. So my biggest exponent is 3, so this is a 3rd-degree polynomial. All right, even and odd degree. So if it's an even, both tails will end in the same direction. And this one, it's even and positive, so they both end up. Okay, so this one, f of x, x to the 4th, okay. My biggest exponent is 4, so it's a 4th degree, which is an even number. And then on the next one, my biggest exponent is a 3, which is an odd number. So the tails will end in opposite directions. And if it's positive, it's going to start down and end up. Okay, so here's kind of a picture to kind of help you out. If it's even and positive, they'll both end up. Both ends will be towards the top. If it's even and negative, both endpoints will be towards the bottom. If it's odd and positive, it'll go from negative to positive. And if it's odd and negative, it will go from positive to negative. And then what down here is at the bottom, that's called end behavior. So for the first one, even and positive, as x approaches positive infinity, f of x, which is your y's, heads towards positive infinity. Okay, and then the next one, even and negative, as x approaches positive infinity, f of x, which is your y's, heads towards negative infinity. Okay, and then the next one is x heads towards positive infinity, f of x heads towards positive infinity. And the last one, as x heads towards positive infinity, f of x heads towards negative infinity. All right, roots, zeros, and solutions are where the graph touches or crosses the x-axis. An nth degree polynomial can have at most n roots. An odd degree polynomial must cross the x-axis at least once. And factors with even multiplicity, which means if you have a factor that's squared or to the 4th power or something like that, to raise to an even power, then it just bounces off the x-axis at that point. All right, so state the zeros and draw a sketch of the graph. So I have y equals x plus 5, x plus 2, x minus 3, and x plus 7. So it's already factored form. So I'm going to take each factor and set it equal to 0, and then I'm going to solve each one for x. So x equals negative 5, x equals negative 2, x equals positive 3, and x equals 7. I just took each factor, set it equal to 0, and then moved it over. So I know it's going to be crossing at each of those because each one is raised to the 1st power, so each factor is odd. Okay, so I'm going to draw a kind of quick sketch. It's not going to be exact, but I know it's going to cross at negative 5, negative 2, positive 3, and positive 7. And I have 4 pieces, okay? So it's even and positive. So it's going to be going up, all right? And it's just going to cross at all those spots. It's going to look something like that. Not exactly, because it's going to be, I don't know what the y values are. It's just kind of a rough sketch. Then the next one I have x minus 3 and x plus 2 squared. So x minus 3, set that equal to 0. X plus 2, set that equal to 0. So I get x equals 3, and I get x equals negative 2. But this one was squared, so it has a multiplicity of 2, which is an even multiplicity, which means it's going to bounce at that spot. Okay, so let me show you what that means. So at negative 2, it's going to touch, and at 3, it's going to cross. Okay, so it's only going to bounce off at negative 2, and then at 3, it's actually going to cross. Okay, and this was odd because I have 1 to the 1st degree, 1 to the 2nd degree, so that makes a total of 3 3rd degree. And it was positive, so it's going to start down, end up. All right, that's it.